Okay, it's time. It's been like 7 years since I started this project, and I can't run from it anymore. It has to get done. This stops now. Hey, I'm Sarah. We are in the panel switch right now, and I am standing next to the sender test frame. Now, this frame has never worked since it came to the museum. And I'll tell you why in just a second. But first, let's talk about what the sender test frame does. Like the name says, this frame tests senders. And in the panel switch, the senders are the circuits that are responsible for giving you dial tone, collecting your dial digits, and moving the rods on the selector frames up and down to actually connect your call. Senders are really complex circuits, and in a typical panel office, there were a lot of them, oftentimes over 100. So they outfitted each office with a special frame that just tests senders. So on this frame, we have a whole bunch of keys and a whole bunch of lights. And what you can do is set up your call on these keys and then run the test. And then if this was actually working, this would iterate through all of the senders and run the same exact test on all of them. The test it's actually doing gets decided by the keys that you punch in here. It's a really nice thing to have, but it's never worked here in the museum. See, nothing's going on. Why? Well, the sender test frame, in order to do its job, needs to send dial pulses out to the sender like a user would, like a subscriber would, and then it needs to watch what the sender's doing with those dial pulses and how it's setting up the actual rods on the panel frame. And in order to do that, it needs two things. It needs a dial pulse interrupter, which is the circuit that generates the dial pulses as though it were a subscriber. And it also needs a revertive pulse interrupter, which is a circuit that generates the little ticks as the rod goes up. Now, we've talked about revertive pulse in other videos. In fact, there was a one I did a year or two ago now where I talked about how I introduced revertive pulse into Asterisk. I'll put a link right there so you can watch that, and I talk about how that works. Anyway, in the panel office, as it existed in its original home over at Parkway, those circuits were on the other side of the room. Now, I've looked at the floor plan for the original Parkway office where this switch was, and I saw where they were. They were not near this, probably because they didn't have space near this. So when they got the panel from Parkway and they brought it here, they forgot to bring those circuits. That wouldn't be a problem, except that the circuits are fairly specialized and they've got lots of bespoke relays in them. And it's not just something you can build in an evening. So yeah, it's gonna be kind of a big deal. Now, a little backstory. I tried to do this a few years ago. I think before COVID, probably in 2018, 2019. And it became apparent as I got started that I bit off more than I could chew. So I got part of the way there, I got as far as I could, and then I just realized I can't finish this. I don't know how. So I put the project away for a while, and it's kind of been sitting off in a corner, banished to the land where it can't hurt me. Back in 2018, I went to the warehouse of my friend Jim, who's sadly passed away now, and was walking around his warehouse of telephone switching, pinball machines, church organs, and letterpress, and I found these circuits. And because I'm insane, I knew exactly what they were the minute I saw them. So I asked if I could grab them. He said, sure, no problem. So I grabbed the circuits, put them in the trunk of the car, and got them back here to Seattle along with a bunch of other stuff. Once I got the circuits back here, it became apparent that they were actually the #1 crossbar version. And because of that, the mounting plates were very long because the crossbar frame is a lot wider. It was still good news because I had many more of the components than I previously did. But the downside, though, is that I have nowhere to put it in here. There's no empty space in the panel office, and there's definitely no empty space for mounting plates that are like that long. So I'm right back to where I started, where I either have to build a custom mounting solution, or I have to figure out how to get this to fit in smaller mounting plates, which I also don't have. So all of this kind of put together made me hit the brakes on this project. And about a month ago, I was sitting at home and I said, wait a second, why don't I just bite the bullet and do this? So let's do it. So here is one of the relay mounting plates that I got from Connecticut, from Jim's warehouse. And as you can see, it's quite long. It's quite long by normal mounting rack standards and the space I have in the panel. The mounting plates are all the same, mostly the same. For this part of the 20th century, they were the C-channel stuff with holes and punchings taken out of it, and then the apparatus is screwed in. But the problem is that I don't have any space this wide in the frame. So I'm going to have to ask our volunteer, Eric, to cut this down to size. And that means that some of this stuff isn't going to be on this plate anymore. So I'm going to need to build or find additional mounting plates, and the circuit is going to have to be rearranged. Like all of the objects are going to have to be put in different places. So I have to do a bit of juggling to make sure that I get all the things in place. And then once I have that, we can start doing the wire form. So I'll give this and the rest of the mounting plates to Eric, and we'll get him to cut them down for me. One of the big problems I had last time was that I tried to build both interrupter circuits, the dial pulse interrupter and the reverted pulse interrupter, at the same time. But when I did that, I found that there were just too many balls in the air because I had to somehow manage to marry the things that I had in the sizes that I had with this circuit and get all the parts lined up, and it just wasn't working. That's what I mean when I say I bit off more than I can chew. So this time, what I'm doing is breaking up the circuits into their constituent parts. I'm gonna tackle the reverted pulse circuit on its own first. And once that is working and I'm happy with it, then I'll go back and tackle the dial pulse circuit. Now, the dial pulse circuit, even though it's kind of doing mostly the same thing, is significantly more complicated. So I'm saving the best for last. I'm sort of using the simpler circuit as kind of a test to see if I can even do this. Then I'll go do the dial pulse circuit. Let's talk just for a minute about schematics. So there are two different types of schematics for every circuit in the Bell Systems umbrella. This is the one that's going to be more interesting to me. This is called a T drawing. And this drawing doesn't show you what the circuit does. It shows you where all the wires go. So here we have a black-white wire that goes from this point to number 1. And then right here is number 1, which you can't see because I have it covered with a magnet. And there will be a black-white wire going to number 7 somewhere over here. There it is. So this wire connects to that point there. Another wire I could pick. There's a red slate wire going from number 11 down to number 53. So if I go to 53 and I look at all my wires, okay, look, there's a wire coming from 11. It's red slate, and it goes to that terminal right there. So this is the drawing that I'll be using to actually build the wire form for the circuit. But for troubleshooting and asking, what does this circuit even do? This is not the best drawing. There's a better drawing. I'll be right back. Okay, this is the schematic. This shows you what the circuit does. Now, it's not done like a modern schematic at all. And fun fact, I don't even know how to read modern schematics. All I know how to read are these. So this is all the bits of apparatus, and there's wires running from every point to every point. From this, I should be able to learn enough about the circuit that I know what it does. I know basically what it does, but not exactly how it does it. Weird Sarah fact time. I am not good at analyzing things by staring at pieces of paper. Never have been, never will be. So what I'm going to do, because it works for my brain, is I'm not going to worry about this. I'm just going to build the circuit as it's drawn on the worksheet, and then, or sorry, on the T drawing there. And when it inevitably doesn't work how I built it, I will then go back and troubleshoot. That makes a lot more sense for my brain than trying to follow all these little wires around and figure out what it does. But even so, I could tell you basically what it does. This relay here is the big controller for the circuit. When this relay operates, the circuit goes. This relay operates when it gets a signal from the test frame. This, and this are the interrupting relays. They operate and release in a timed fashion based on closing like a self-interrupting battery and ground through resistors. So once they start moving, they open and close their own operate paths. And when they do, they open and close it through resistances, which causes them to oscillate or flap. But it's controlled flapping. And by tweaking the value of those resistances, you can precisely control the flapping. And these relays are of a type that is also precisely adjustable. So they don't just flap in a sort of uncontrolled way. It's very, very bespoke flapping. So let's get rid of this diagram because I don't need it right now. Yeah, magnet that up. Oh, God. Diagram down. But now you know a little bit about the two types of drawings. There's the SD, which is that, and then there's the T. And this is the one that's going to be more interesting right now. In case you're wondering, that's a terminal block. These are fancy resistors. That's a relay, that's a relay, that's a relay. These are condensers, which the kids these days would call capacitors. And these are all resistors. And this is a 48-volt bus, and that's a ground bus. And then these relays here, numbered 47 through 53, these are my big fancy pulse oscillating relays. And these two things here are jacks. Okay, I will see you when we have all the parts ready. The first thing I did was get out an old piece of plywood that I'd started with many years ago. I removed the old wires and pulled all the old nails out. Since I'm starting over from scratch, there's no point in keeping them. After that, I laid down new paper that I got from the local arts and crafts store. This was basically the cheapest, largest paper I could buy, which is fine because I only need to use it once, and I just wanted a ton of it. So if I made any mistakes, I wouldn't feel badly about removing it and starting over again with some new sheets. The goal here is to create a nice surface that I can draw and write on. Since I'm making this circuit from scratch, I need to know where all the pieces are supposed to go. Then, I laid down the mounting plates and started drawing in the locations of all the equipment. The lines here don't have to look nice just as long as the equipment itself lines up correctly where it will appear in the frame and everything is parallel. With these capacitors, I needed to double check which ones went where and make sure I wasn't forgetting anything because it would not be fun to discover that something was missing after I finished the wire form. Now, I hammered some nails into each point where the wires need to leave the form and connect to a piece of equipment. I'm purposely not driving the nails in too hard here because I don't need to, just as long as they hold. I'd rather have plenty of space on the nail sticking out of the board so I can run wires comfortably and things don't get too crowded. Now comes the hard part, running the actual wires. To do this, I had some other volunteers look at the drawing and read off exactly what wires go where. I have enough spare wires that I can mostly match the original colors, which will make it easier when I have to go and connect everything. This part was the hardest for me, since my dyslexia and dyscalculia make it so that the person helping me had to say the name, color, and location of the wire several times in a row. We're obviously speeding up time a lot here in the video, but this took me a good portion of the day. It did eventually get done though, and that patience paid off big time. Sorry you're looking at it sideways, but that's the only place I can put the camera where you're going to be able to see anything. So I'm going to start lacing this up, and right now it kind of looks a little bit like a mess, and it kind of is, but as I lace it up, it's going to get its own strength. And I'm going to start lacing here. I'm going to build these arms first, I think. Lacing is one of those things that it's an art form, and just like any other art form, you need to practice a lot. And I used to be very bad at it, and now I'm okay at it. And I'm probably better than okay, but I think I'm okay because I'm a perfectionist, and I don't think I'll ever be, as good as I want to be with it. So we're going to do a little trick here because we're building this form from scratch. We are going to, let's see, we're going to double back on the twine, like so. Get it to about the same length. And then we're going to do this. We made a little thing. And starting right about here, I'm going to put that under there. And I'm going to put it through the little loop that I made. And I'm going to coax it so it's nice and tight. Lacing is all about coaxing, coaxing it where you want it to go. Okay, so half of this is going to go up, and half of this is going to go down. So yeah, I'm going to have to use the needle at some point because there's a giant piece of plywood in my way. And normally if I'm lacing in a frame, I have some room. I have some room to exist, but here I do not. So this was a really tough project for me, like I said, and I put it off for many, many years. I think it was about 5 years I put this off for because of the difficulty for me in being able to remember numbers and colors in sequence. And even with somebody helping me, this took me an entire afternoon. Not because I'm not good at doing wires, but just because I kept having to ask them to repeat the numbers they were reading me so many times before I could finally remember for more than a moment what they had just said. I'd much prefer this kind of work than anything else, because at least with this, I'm working with my hands and it's just very calm and relaxing. Kind of makes me feel like one of those carpenters on those PBS carpentry shows. I don't know if you know what I mean. Sometimes you watch like someone doing work that they're really good at, and it's kind of zen and relaxing. And like watching Norm Abrams, the carpenter, when I was little, was like that.
This thing here is going to a terminal strip, which is why it's off going off in a weird direction. This relay was really tough. This is the SP relay, and this has got like a bajillion wires going to it. And then the resistors down here are pretty empty. So yeah, it's pretty good. I'll do better next time, but I'm reasonably happy with it.
In the next video, we're going to have to start mounting the equipment in the frame. The only problem is that I need to run disk defrag on the circuits here because they've changed a lot over the years and things are kind of spaced out awkwardly. I don't have a lot of contiguous free space to use for my new circuits. So in the next episode, we'll get the chain hoist out and move some things around and see how much space we can recover. See you soon!